40 years ago. I remember when I was a young boy carrying water from here. My parents would tell me to go get water, and I used to just swoop away the little water bugs and get the water, and we used to drink and bath and cook from it.
The Fisher River Watershed, located in the Interlake region of Manitoba, is approximately 315,000 hectares and is the most northern agricultural extent within the Interlake. The Fisher River flows northeast, passing through the communities of Fisher Branch, Hodgson, Dallas Red Rose, and Broad Valley. It includes land located in the rural municipalities of Fisher, Bifrost, and Grahamdale, and those managed by Manitoba Aboriginal and Northern Affairs, the Fisher Bay Park Reserve, and the Fisher River and Peguis First Nations, before it finally finds its way into Lake Winnipeg. The Fisher River Watershed has a limited agricultural landscape, with most of the watershed covered by wetlands and forested areas. The majority of the agricultural lands surround the towns of Fisher Branch and Hodgson. In March 2009, the East Interlake Conservation District became the Watershed Planning Authority to develop a comprehensive integrated watershed management plan for the Fisher River Study Area. A project management team was formed.
I think the importance of the plan and the team coming together is obviously to protect the environment, meaning water and the land use, etc.
The Fisher River Integrated Watershed Management Plan can be broken down into two main components: the goals and the actions towards those goals. The project management team engaged the community in a variety of techniques, which included public engagement meetings, a watershed team meeting, an open house held by the East Interlake Conservation District, door-to-door input from residents, website input through the online surveys, mail-in surveys, and traditional knowledge interviews with longtime residents and First Nations elders. The project management team considered the assets and issues identified by local residents and the watershed team. 4 primary assets were identified: natural areas, drinking water, surface water quality, and protecting agricultural land and communities. The goals of the plan were developed based on these assets and issues, and the plan was ordered to reflect these priorities.
As the needs were expressed, they naturally broke down into different categories, and that helped to really see things. And then when you brought all of them together in that big meeting that we had at Fisher Branch, you had each of the individual goals from the previous meetings, and you could really see things starting to turn and shape.
Protect and restore natural areas.
In our way of life as Anishinaabe people, we go through many teachings to share about what the elders have talked about disturbing a lot of the creeks, drainages, because that's all a filter. No matter where it comes from, the Creator had put that there. So, and Mother Earth will look after everything else. And we start taking everything out from her and taking things away from her and trying to make things better for ourselves, we're actually decreasing our lifespan.
Ensure safe drinking water.
In order to ensure safe drinking water, we're going to have to get all of the people to come together and agree that that's what they want to do.
Preserve and improve water quality in lakes and streams.
The water is life for all of us, and what I mean by that is when a child is born, that water is broken and then that life is given. And it's the same thing here in the world today. If we don't look after that water, there is no life, there is no future for our children, our grandchildren.
Coordinate surface water management to protect communities and agricultural lands from floods and droughts.
More infrastructure within our tributaries to the river, for example, would help.
One very special feature that was identified early on in the planning was the presence of a globally rare ecosystem known as alvar. An alvar is a plant community that grows in soil depths of less than 10 centimeters over limestone bedrock. These ecosystems contain plant species found in no other plant communities and are also habitat for a range of wildlife. They contain poor surface drainage and are typically flooded after spring snowmelt or heavy rains, but dry out rapidly. The effect of too much or too little moisture creates a stressful environment that limits the number of plant species that can survive and generally stunts the growth of those that do. The stressful environment eliminates many competitive plants, allowing the establishment of rare or unusual species of plants, birds, and invertebrates. The Fisher River Watershed is home to Manitoba's largest alvar. It's located in a 22-kilometer by 2-kilometer wide region between Fisher Branch and Hodgson. Alvars in the Fisher River Watershed appear to be groundwater recharge areas. The areas are raised above the surrounding landscape and have poor surface drainage. The flat surface area prevents overland drainage. Water ponds on the surface where it creates seasonal wetlands, which form after spring melt or large storms, but dry out later in the season. Water slowly recharges the underlying carbonate aquifer or is lost to evaporation. Several of the alvars in the Fisher River Watershed are adjacent to biologically rich wetlands, which are fed by groundwater discharge originating from the alvars. Manitoba Conservation and Water Stewardship is working with the Nature Conservancy of Canada to place 4,000 hectares of alvar lands under protection. Conservation plans for alvar should include the protection of groundwater discharge wetlands, which often originate from the alvar.
I'm really excited about the chance to build a new tool for Manitobans to use. This tool is going to pinpoint exactly where in the watershed we should be placing projects like small dams, which will hold back water to reduce peak flows and nutrient runoff.
The East Interlake Conservation District is using light detection and ranging LiDAR technology to better map watershed elevation levels in the region. LiDAR is collected by a plane with a GPS and laser unit. As the plane flies over the land, it sends out a laser pulse, which then rebounds off the earth and tells the plane the elevation of the ground within centimeter accuracy. The East Interlake Conservation District has teamed up with the International Water Institute and the Province of Manitoba to develop a watershed planning tool that utilizes this LiDAR data. The East Interlake Conservation District, with their project partners, are currently creating a similar tool in the Fisher River and Icelandic River watersheds that is successfully being used on the U.S. side of the Red River watershed.
This was the 4th Integrated Watershed Management Plan by the East Interlake Conservation District. And by all accounts, this watershed is the most highly biodiverse, with lots of wetlands, grasslands, forest, and alvars. And with its biodiversity comes really great water quality, both surface and ground. But yet the residents here are really concerned about the water quality, both surface and ground, and they want to make sure that the things we do today do not affect generations to come.